Today's session is on photodiode. A photodiode is a semiconductor device that can convert light into current. So in this diagram, we can see different types of photodiodes. Photodiode, then infrared LED. These are different types of photodiodes. Then the circuit diagram of a photodiode is shown in the figure. So here a p type material is there and the n type material is there. A resistance is connected and this p type is connected to the negative terminal of the battery and the n type is connected to the positive terminal of the battery. That means this pn junction is connected under reverse biased condition. So what is reverse biasing? When p is connected to the negative terminal, in p region holes are the majority carriers. All the holes goes to this negative terminal. In n region, electrons are there. All the electrons moves towards the positive region. So the width of depletion layer increases, and at this time the light energy is incident on the junction. So in the junction, we know that there are immobile charges. That means charges with no mobility. When light energy incident on this, free electrons are generated. When a free electron is released, a hole is generated. So this free electron hole generation occurs. So due to the flow of this free electrons and holes, if an electron is generated, that electron crosses the junction and moves towards the positive region. When a hole is generated, it moves towards this negative region. So due to the flow of this minority carriers, a reverse current is developed here. That is the working of photodiodes. So this working can be explained through this diagram. A p-type material is there, n-type material is there. It is connected under reverse bias condition. P is connected to negative, n is connected to positive. In P, majority carriers are holes and in N, majority carriers are electrons. So when P is connected to negative, all the holes moves towards this negative side and all the electrons from N region moves towards the positive side. So this dotted line represent the width of depletion region. So width of depletion region increases. When light energy incident on this depletion region, this minority carriers are released. That means electrons are released and holes are generated. So due to the flow of this minority carriers, a reverse current is developed. That is the working of photodiode. Then different types of photodiodes are pin photodiode, PN photodiode, that means junction photodiode, and avalanche photodiode. First we can explain pin photodiode. So here these photodiodes are working under reverse bias condition. So in pin photodiode, a p-type material is there and n-type material is there. So in between this p and n-type material, an intrinsic semiconductor layer is placed between p and n region. Then when it is reverse biased, that means P is connected to negative terminal and N is connected to the positive terminal of the battery. What happens to a circuit? The depletion layer, the width of depletion layer increases. And at some point, the width of this depletion layer, here it is given that during reverse bias, the width of depletion region increases and at certain reverse voltage, the depletion region cover the entire intrinsic region. That means the width of depletion region becomes equal to the width of intrinsic material. Hence, the incident light energy is incident on this depletion region. So when light energy is absorbed by this PN junction diode, the area of absorption get increased. Here in normal PN junction material, PN junction diode, the light is incident on this junction, but here due to the longer area, the area of absorption of light energy get increased. Hence a large amount of reverse current flows through the circuit. If light is incident on the depletion region, what happens here? Immobile charges are there. That light energy is absorbed by the immobile charges. So a free electron is generated. If a free electron is generated, a hole is also generated in the depletion region. Then holes moves towards the holes moves towards the negative terminal and electrons moves towards the positive terminal. Hence a reverse current flows through the circuit. The flow of this electron pair create current that is called photocurrent. So this is the working of pin photodiode. Simply we can say that when a pin photodiode is connected under reverse bias condition, the area of depletion region becomes equal to the area of intrinsic semiconductor. Then light energy incident on that intrinsic semiconductor region, free electrons generated. If a free electron is generated, a hole is also generated. So by the flow of this electron hole pairs, a reverse current flows through the circuit that is called a photocurrent. This is the working of pin photodiode. Then PN junction diode. PN junction diode is similar to photodiodes. Here a p-type material is there and the n-type material is there, and this region is the PN junction, that means the depletion layer. When this photodiodes work under reverse bias condition. Reverse bias condition means P is connected to the negative terminal and N is connected to the positive terminal of the battery. When under reverse bias condition, all the majority carriers of p side, that means holes moves towards the negative side and electrons moves towards the positive side. So when the depletion layer, the width of depletion layer increases. At this time, when light energy or photons incident on this layer, free electrons are released. When a free electron is released, a hole is generated. So by the flow of this electron and hole, a reverse current is developed through the circuit. That is the working of PN diode. So it is given that works under reverse biasing. The potential energy barriers between P and N region increases. Free electrons and free holes cannot cross the barrier and no current flows. When light energy is incident on this, free electrons can cross the junction. A large amount of free electron hole pairs generated. Electrons are attracted towards the P region and holes towards the N region. Thus, current pass through external conductor. Amount of current depends on the intensity of incident light. That means how much amount of light is incident on this PN junction, that much amount of current is reverse current is generated in the PN junction photodiode. That is the working of photodiode. Thank you.